Welcome back to the Health Physics Society's video series pursuing the truth and promoting transparency regarding the historical foundations of the current radiation protection philosophy based on a linear no threshold theory for cancer risk assessment. I'm Dr. John Cardarelli, President of the Health Physics Society. In the 19th episode, we learned that Howard Andrews, the Executive Secretary of the BEIR Committee, had to modify the final BEIR II report to incorporate the findings of genetic repair, due to the urging of Russell and others on the committee. In this episode, Dr. Calabrese describes how this work evolves from the Committee on the Biological Effects of Atomic Radiation to the Committee on the Biological Effects of Ionizing Radiation. The U.S. Environmental Protection Agency assumes the oversight of the new BEIR Committee in 1970, and by 1972, the first BEIR Committee provided its recommendations, which acknowledged genetic repair but stayed with the linear no threshold model for cancer risk assessment. Why? Watch and find out.
So they're doing this as a policy matter and not necessarily saying this is what the science definitely tells us to do.
Well, I think that that's probably true, because the science is telling them now new things. The science is actually refuting, potentially refuting that position. The science is still new. It's developing. It's developing mostly out of Russell's domain, and these studies looking at repair that Russell were doing, these were unique and massive efforts. And Russell, now I would have to say, just so that you're a little bit aware of Russell. Russell started this work at Oak Ridge. He was the first hire, so to speak, in the post-war time period in which they were going to go in a new direction, and they were going to look at genetic risks, and they were going to use the mice. And so he was recruited from Jackson Labs up in Maine down to Oak Ridge to undertake this sort of a project. And Hollander was the person in charge, and Hollander hires him to get this going. And so what happens in their first real publications in 1951, and they're using the mouse model, and they're using, they call it a specific locus test, and they're using recessive characteristics that are homozygous, and they have seven traits, and they're trying to do this because they want to be able to see. They're really focused in on recessive traits, but they want to see them in the very first generation, so they don't have to wait too long. And so that's why they have homozygous recessive traits, and they're able to evaluate this. And they show with radiation exposure, that the radiation is causing damage to all their different loci that they're studying, and they're trying to take a look at how much they're trying to compare it to the Drosophila. And so what they find out in some of the preliminary experiments in 1951 are suggesting that, in fact, that the mouse is about 15 times more sensitive than the Drosophila. And this is very interesting because even though it really wasn't all laid out that well, it was quite obvious to Russell and his colleagues that the mouse was more sensitive. And that maybe, what should be the model for humans? Should it be the Drosophila, or should it be a mouse? Well, I think most people just say, I'm going to lean on the mouse and go that way rather than a fruit fly, right? And so what happened is he begins this study of mouse mutation, and it's a very weird sort of a thing, and maybe because he was at a national lab, and what he ended up doing was, before he was done with it, he ended up studying over 3 million mice. Talk about the million-man study. This is like the 3 million mouse study, right? And he was in this process, and so his initial work was very successful in showing, wow, yes, I mean, not that surprising that it's going to cause mutation in mouse, but that the mouse might be 15 times more sensitive than the human. That's interesting and maybe very important. And so what happened is that this continued, and then in 1954, there was a student or a postdoc sort of a person down in Oak Ridge, a Texas graduate student who was doing work at Oak Ridge, and she was able to quantify the difference between fruit flies and humans in a very comparable sorts of a way, and she confirmed there was 15 to 16-fold difference. This was very big.
Is this a comparison, you said, between flies and humans? But
yes.
Was it between flies and mice?
No, it was between flies and the mouse model of Russell. And they tried to match up the genes and the autosomal loci, the things to the best that they could possibly do. And they not only affirmed the greater susceptibility, but they were able to really quantify the differences. And so this got out in the literature, and then what happened is that but still the field is dominated by Drosophila geneticists. Then the BEIR committee comes on the scene, and so Hollander and Russell get appointed to this. Now I would point out to you that back in the 1930s, that Warren Weaver, who is the director of research, for the Rockefeller Foundation, was funding much of the work of Alexander Hollander and had a strong relationship with him, funding-wise and otherwise. And so when he was putting this BEIR committee together, he obviously chose people that he knew and had influence with, and Hollander, brought Russell along to the committee, and Russell was a young guy at that particular point. Now, what happens in the committee is it's very interesting and it's very coy, and that is that Russell really wants to move, advocate for his mouse model. At the same time, he's in with people that have dominated the field. Everything has all been Drosophila, and so he's coming in and saying, I think it's the mouse model, and my mouse model is 15 times more sensitive than your model. What does this really mean? Well, you know what the obvious answer is. It means my model is more significant than your model. But he's trying to, it's this delicate balance between, he doesn't want to get Muller especially, and maybe some others, but especially Muller, angry with him. And he's coy in what he does. And so ultimately what happens is that when the decision is really made to support LNT, it's really based upon Uphoff's and Spence's work, and not on Russell. Although Russell's work was there and was known, but Russell was a bit coy in how to play this. But at the same time, he wanted his work known, and he got it out there in the literature, and he made all these inferences that, well, what does this really mean about what's the best model? And any intelligent person is going to know that without being told, the best answer is going to be the mouse compared to the fruit fly. But he didn't really want to be so stick it in the face of Muller and so forth. And so there's an interesting game that's going on with him, and then he has his big discovery. And the discovery is in 1958 that we've just gotten discussed. And so and despite this, it still didn't affect the precautionary principle and the LNT recommendation. And so how this moves forward is that he keeps doing more work with more animals and more permutations, and then eventually what he finds when he's really up the ante of numbers, large numbers of mice and rats. We're talking tens and 20s and 30s and 40s and many thousands of animals. They had built a big mouse house. They had at one point they could process 250,000. They could hold 250 mouse all at one time. He got major funding and built an empire down at Oak Ridge. All that came out of this work. And they were, talk about big science, it was big science. No university could compete with this government-funded research entity. I mean, you might have 300 mice if you're lucky in a study. Russell's dealing at one time with 250,000. And all the people that he's in charge of and all this, it's an empire that ultimately evolves down there. And at some point in the early 60s, what happens is that he makes the conclusion that with female, and he's studying as compared to Muller and the others, they studied mature spermatozoa. He was studying spermatogonia and oocytes in their more undifferentiated state earlier in the phase. And he did that for a variety of reasons, because he felt that in preliminary studies, when you dealt with mature spermatozoa, that in fact you couldn't get a good straight linear dose response at high doses, and he wanted to play around with dose rate. And when he started playing around with dose rates with spermatogonia, he saw unexpectedly this finding. He didn't intend this, but what happened was that he found a true threshold for mutagenicity with the female. He found that when you expose the females to approximately 30,000-fold above background, that there was a threshold. Below that, the whatever damage that you were creating in the female had a capacity to repair that damage. And that was a really major finding. It was really 27 to 33,000 fold above background that they reported, And then when you looked at the male, well, the male had really very substantial, I'm going to say genetic repair damage capacity, as the female did. But the female was performing better than the male, and the male was able to at the comparable level of exposure to the female, reduce the damage from acute exposures and otherwise by about 70%. But they never got it down to a threshold, and so the male was still always going to be having some damage that didn't seem to be repaired, but the female was clearly showing a threshold, and they could have used a lower dose with the male, but there was methodological problems with the length of the reproductive cycle and waiting for cells to go through, and trying to relate that to basically protracted exposures. So they couldn't quite ferret that out very well with the male. And my belief was that they would have probably seen a threshold if they could have actually worked it out, but they couldn't work it out. So they didn't know. They actually didn't know. But what they did know was that the female showed a clear threshold. And so that was interesting. It was really interesting. And so on a policy side, back in 1963 with the International Committee on Radiation Protection, Muller was on it, and one of the people from Oak Ridge was there, and they brought William Russell in to discuss things with Muller, and they got into quite a at this point this set of disagreements over how to use this information within risk assessment. This got very, very interesting. It's the first major confrontation. And Russell had taken a much more aggressive stand at this point towards, I think you can probably use this in human risk assessment. And Muller was saying, well, I don't think we can use it in risk assessment because it's not really resolved between the insects and humans and how this all works out together. And they had added the silkworm to this species.
But at this point in time, then, Muller had already done some work again with the flies that also demonstrated repair.
Absolutely, that's correct.
Okay, and now there's also research with silkworms.
That's right.
So we have 3 species that do show a repair mechanism.
That's right. And so in this, and Russell really wasn't part of the committee. He was brought in as an advisor to the committee, but I have all their documentation, and he pushed it, and Muller pushed back, even though they really knew that the repair was clear. And Muller had argued that he felt that repair would even be stronger in a mammalian model than an insect model, and he published those papers and the like. But when it came to actually advising the ICRP on this matter, Muller was very reluctant to allow the dose rate and repair issue to impact any thinking. Even though it was evident, even though it was repairable, it was too premature to impact predictions on human welfare, and did not want to go in that direction, whereas Russell really wanted to. And Russell wasn't really part of the committee, and then kind of just withdrew. But this whole thing was a very interesting battle between the two. Now, it gets very interesting further on. In 1967, Muller dies. And then in 1970, at a conference in France, Bill Russell attends, and this was actually amazing. He makes a break, a clear intellectual, philosophical break with the radiation genetics community. And he said, all these assumptions that we have been living under, he said, they don't apply to mice. Okay, they don't apply to mice. That's my area, okay? And so he's staying within his knowledge base, right? And he criticizes everything from the basically cumulative damage and irreversible, it's not repairable, linearity. He just slammed it. And so for the night, and I thought that, well, here's a prominent guy. He's now, mature person. The big beast is gone and died, and now he can speak freely and really let it all go out. And he does. And I thought that this was like the clarion call for a revolt and fresh air into the field, right?
And this was at a meeting of the ICRP?
No, it was a radiation research meeting over in France. And so he makes it, the proceedings themselves and he was upset because the proceedings took 3 years to come out. Sometimes that can happen in the publication domain. And so his words took 3 years to be read. And so Bill Russell, at that point now, by the time he is in 1973, he has reached the age of 63. And there was a permanent retirement obligation within the federal government. You had to leave at 65. So 2 years from that point, he was actually going to be forced to retire from running the whole operation that was out there at Oak Ridge. And so it's all, a lot of this timing. And so, but in 1970, at the same time, it's when EPA was created. And right before EPA was created, the Federal Radiation Council had recreated the next version of the NAS's, BEIR committee, but they now called it the Biological Effects of Ionizing Radiation, BEIR. And then it was going to be BEIR #1. And so that was put together in 1970, and it was really put together by the Federal Radiation Council. They go out of existence, and then it's then taken over by EPA. And so it's viewed like EPA funded it, but actually who created it was the FRC. And so now, as it turns out, there are 3 holdovers from I guess it's 14 years earlier for the BEIR I committee, and they have Jim Crow and they have Bill Russell, and who's the other one? I'm kind of blocking on the other one now, but.
I'm not sure I can come up.
But whatever it is, they have 3, and it's Neil. So Neil. They have the 3 young ones, and so as it turns out, they go forth, and I would have figured, and actually Crow becomes the chair of the committee, and he's really the offspring of Muller, and so they're all talented. They're all senior people now in the field, lots of experience, strong committee. And so what happens in this, after 2 years, they make a recommendation that goes to the EPA as to what they should do. And in this recommendation, this is like the modern era, the real modern era with BEIR I and then continuing to the present time. They look at the decision that the BEIR I committee made in 1956. And one of the big decisions was that dose rate is wrong. There is a dose rate. That is, damage is predicted by cumulative dose, the piggy bank model. And so they said, we were wrong. We were wrong. The Russell data has proven us wrong on that point. Dose rate is real, and we were wrong. And so they followed the data on that particular point. However, they said, because I was wondering, because I know that they're all wedded to LNT, so how could they get out of this thing? And so they got out of it by saying, well, even though there is a threshold dose for the female, we know that's true, but Russell's data do not show that there is a threshold yet for the male. And so we are going to continue with recommending the LNT. And that's very explicitly written in the write-up of this BEIR I.
The BEIR I committee.
And then what happens is that it's kind of the modern era. I mean, I'm getting up there myself in terms of my young professional stuff, right? And then in 1975, the US EPA looks at that 1972 report and they rubber stamp it. And they say, based upon the recommendation that was heavily underwritten by the research of Russell and so forth with all his mice and so forth, we are going to support LNT.
Thank you for watching the 20th episode on the historical foundations of the linear no threshold theory, where we learn that despite the acknowledgement of genetic repair, the newly formed BEIR committee recommended continued use of the linear no threshold model for cancer risk assessment. This recommendation was based on Russell's work with mice, in which female mice showed a clear threshold about 27,000 times above background dose rate due to genetic repair, but the male mice did not. That said, there was a 70% decrease in the effects from an acute exposure to radiation to a chronic exposure, but a threshold response was not detected. Based on those findings, the linear no threshold model was recommended in the 1972 BEIR I and 1975 BEIR II committee reports. In our next and final episode, new information is discovered. A mistake was made. What was it? And how might it affect future policy regarding radiation risk assessment? Check it out. The HPS is a trusted source of radiation information. We're a scientific organization, and as is offered with a scientific peer review process, viewers are encouraged to send comments or suggested corrections to factcheck@hps.org, and be sure to include your sources so that we may correct the record if necessary. If any changes are made, they will appear at the end of this episode. Please visit our Ask the Experts website to ask questions or seek answers to common radiation-related questions, and view our fact sheets. We also have official position statements that can be found at hps.org. Finally, if you wish to join the Home for Radiation Protection Professionals, please visit the link below. We welcome you.